So this is the part 2 of the Mortal Kombat, and I'm getting closer to making the Sun Gong Quan Scandal homebrewed game, but I'm gonna take it to the DS3 because this isn't working. I had to find the sources from all different places, and I basically have everything about micro Lua binaries or source code, and you cannot successfully compile it not without coding something yourself. The creator Raylac, he's a moody genius or something. He doesn't have time to make sure his source code for recompilation works, and this project has been dead for years and years. Because I'll let you know, I didn't see this through right now. I'll get to the solutions at the end, so let's start where we left off. I wanted to rotate sprites by possibly adding C code for sprites and updating the Lua bindings. So let's find the source code for sprites. This appears to be the fundamental logic. This is what screen.blit is built on, and this is what Sprite uses. So where are the Lua bindings? This is the C file where the binding is located. This is the C function that is called when you use screen.blit in your Lua code. The Lua underscore state is the Lua state, which allows this C function to interact with Lua. This line likely comes from a table within ds underscore screen.c that registers the C function screen underscore blit with the Lua name blit within the screen module. So you can see where UL draw image XY is defined, and that inline part is part of the bigger problem. But that's because micro Lua sprites actually depend on image and screen.blit, not the C code for sprites. So I would be building Lua bindings completely for this C code. So let's take a break to look through the whole grep return for Sprite. There's a whole file for Sprite rotate. Sprite rotate. The sprite table I found in libs.lua is indeed a declaration of the sprite, but it is a Lua implementation of software sprite / image animation, not Lua bindings for the DS hardware's object attribute memory sprite functionality. So this is definite proof micro Lua does not provide Lua callable functions to directly control the DS hardware sprites. The sprite object in libs.lua is a higher level abstraction built in Lua itself, relying on basic image drawing like screen.blit. palette rather than interacting with the low-level sprite hardware. So at this point, yes, I can do what I was doing in C, but I'm trying to make this so you can change this, change that, and you're using a continuous integration built to AI generate your own games. C is too low level to be ideal for that scenario. irqLock is the candidate solution, but at this point it's too simple. The specific features of hardware sprites like automatic scaling, rotation via affine parameters, blending modes, mosaic, priority lighting interacts correctly with backgrounds. I would need to write the C-level Lua bindings, like for the libnds OAM function I would have to do myself. So okay, that's what I want to do. That's my plan of action. Let's get a practice compile list before I add my own file. But just by the way, these are the C functions I will make bindings for. The example demonstrates sprite rotation by calculating a rotation angle based on user input and updating the OAM in each frame using OAM update and OAM main to apply the rotation and display of the sprites. And so it's a lot more efficient than pre-rotating sprites like Gemini had been insisting I do. So libnds sprite API from sprite.h. This gives you fine-grained control over individual hardware sprites and manage parts attributes like position, size, flipping, rotation, palette, etc. directly in the OAM. Functions like OAM sit flip, OAM update are part of this API. OAM rotate scale is the core function for setting up sprite rotation and scaling. This is the directory. This NDS folder will actually make the NDS executable with no microLua bindings. So that's the first mystery, because it's supplied by devkitPro, not microLua. A person like me who doesn't know C has to wonder how the Lua and microLua is mounted in the make file. That's what the bindings are. But I can't get a successful build of the NDS executable because of the missing Wi-Fi code. I downloaded this library that's supposed to have the passive Wi-Fi. It still doesn't have these AP scan feed functions. The errors in NDS Wi-Fi.c point to issues with the Wi-Fi functionality of the microLua DS project. So it was too much problem to get Wi-Fi to work, so I just removed the Wi-Fi. The updated libnds was supposed to make the Wi-Fi work. That's what the wiki said. There's a bunch of little edits you gotta make to get this root make file for the microLua to compile, but I never successfully linked to make the L file. I'll just put it in the description all the little errors and their fixes. So the only way I could get the compiler to finish is to gather all the static libraries in libnds/lib. So I was looking to solve the undefined reference errors first. IRQ enable SWI wait for vblank and SWI copy. These are core libnds functions defined in libnds.a. Gemini kept telling me I was missing GL init C. This function is part of the libnds's OpenGLES subset library, typically linked via LGL9. But this makefile for its library in ds/graphics doesn't make a static library. But I think I'm building a new library which is dependent on Calico, but that's microLua, so I don't get the difference between how I'm supposed to use this graphics library, which does have this GL it's talking about. I'm thinking I'm building microLua bindings that have 0% compatibility with the NWS executable I'm making. Looking at my libs variable in the root makefile, this is the correct order for dependency, but I have circular dependency. And when I grep define definitions, if I don't have any C source files, I'm wondering when it brings up an A file if the definition is there, the function is being called, but my undefined reference errors give me some clarity. The problem with these undefined reference errors are some of the functions are being defined inline. The previous undefined reference errors for SWI wait for vblank was due to the hashtag define became thread wait for vblank were happening because even though the definition is inline in the header, the linker still couldn't resolve it. This happened because the compiler doesn't inline the functions everywhere it's called. Knowing that thread wait for vblank is an inline function, Calico's header confirms as part of the Calico library implementation of core system functions. So Calico is necessary to build the NDS executable. DeepSeek will tell you Calico is deprecated when you're trying to compile U library. The whole DS homebrew scene is deprecated. Don't believe it. Don't try to edit out your Calico dependency. I think Calico just wasn't built right for these dependency, and there's no makefile for my Calico sources. And then I have multiple definition errors, which as far as I can tell, I think stems from the same problem that's causing undefined. One of these A files isn't built right. The trend is that U library source code is being compiled and included in the build process from at least 2 different places. It's being compiled and included when liblua.a is built. This results in compiled U library code being R archived inside liblua.a. It's being compiled and included when my main project's object files like main.o are built. This results in compiled uLibrary code being present on my main project's object files. When the linker runs, it sees the same uLibrary function or variable defined in both the object files from liblua.a and the object file from my main project, leading to the multiple definition error. And so that would be a problem with the include statement in lua/src. And so I'm going to get to that in a second. We have seen evidence that uLibrary calls functions in libnds9.a, libgl.9.a, and libcalico.h9.a. From libul.errors needing SWI copy, GNL init c irq enable SWI wait for vblanket irqLock. libnds9.a calls functions in libcalico.h9.a. From libnds.9.a keyos. So my solutions are remake Calico. This requires writing a makefile, or remake libnds. So this requires swapping out from devkitPro, or remake uLibrary because it has dependencies on Calico. Gemini is stuck on telling me this start group and end group will make all the difference, and telling me I need to change the first couple of statements in my include statement in the Lua src makefile. But it won't compile without those statements, so at this point it's a wash. If you're familiar with this situation, tell me which library I should rebuild and I can revisit it. I just wanted to give you the idea of the process of modifying source code. I'm hoping I have better luck when I add BCE date handling to PyTorch Lightning's time series object.